नमस्कार, म रुद्र काफले उत्तर म्यासाचुसेट्सबाट एक दुई मिनट म अगाडि नै मैले चाहिँ लाइभ आएँ। यहाँहरू चाहिँ हेर्दै हुनुहुन्छ होला। यो प्रोग्राम चाहिँ विशुद्ध विज्ञानको विषयमा हो र हामीले चाहिँ फिजिक्स इज फन भन्ने प्रोग्राम चाहिँ सुरु गर्न गइरहेछौँ। त्यो चाहिँ ठ्याक्कै अब 3-4 मिनटपछि सुरु हुन्छ। यहाँहरूले हेरेर प्रतिक्रिया दिनुहोला। एक दुईवटा लेट्स सेट अप couple of rules. If you are watching, if you are small children, so please take help from your parents or teachers or guardians, whoever are attending there. So please let me also check my volume. I believe the volume is good, so let me make as much as I can in this system. Okay, so so I hope you guys can see everyone. Can you hear me well? Okay, so if not, please make comment. Okay, good. Okay, thank you. Let me tell you one more rule. So if students are repeating the experiments which I am doing here, so please parents and guardians, please help them do the experiments very safely. Okay, so with that we'll start the class today. Let's wait for 2 minutes. If you cannot hear me well, so please make a comment, so I'll adjust my volume. I was trying to come in computer, but there is some kind of system problem in computer. I realized that. So they say that the browser is not supported, particularly Chrome doesn't support the Facebook Live. So I need to go to other browsers, in particular Mozilla Firefox. I also saw some kind of issue in there. So I am doing this in my phone. Okay, so could you please write a comment whether you can hear me well? Can you please write a comment? Can you hear me well, please? Okay. Yeah, thank you. Okay, good. Okay, yeah, thanks. Okay, thank you so much. So we'll start in 1 minute. So it is 9:14 a.m. in the United States and about 7 p.m. in Nepal. So we are going to start in 1 more minute. Yeah, we can hear. Thank you so much. Yep. Okay. So as I promised, we will be doing Newton's laws of motion today. Okay. So Newton's laws of motion. So I will be doing some demonstrations and I will explain. तपाईहरु शिक्षक साथीहरु हुनुहुन्छ भने आफ्नो स्टुडेन्टहरु सबै हुनुहुन्छ भने उहाँहरुलाई हेल्प गर्नु होला। पेरेन्ट्सहरुले पनि केटाकेटीहरुलाई चाहिँ हेल्प गर्नु होला। So this is exactly 9:15 a.m. in US Eastern Time, according to US Eastern Time, and 7 p.m. in Nepal. So नमस्कार, यहाँहरु सबैलाई चाहिँ म हार्दिक स्वागत गर्न चाहन्छु मेरो फेसबुक लाइभमा। The name of the program is Physics is Fun. Okay, यसको प्राइमरी उद्देश्य एकपल्ट म फेरि रिपिट गरौँ। यसको प्राइमरी उद्देश्य हो केटाकेटीहरूलाई फिजिक्स प्रति मोटिभेट गर्ने, उनीहरुको लर्निङ कन्सेप्टमा चाहिँ मोटिभेट गर्ने, उनीहरुका लागि कन्सेप्चुअली लर्न गर्न चाहिँ मोटिभेट गर्ने हो यसको उद्देश्य। राइट, त्यही उद्देश्य अनुसार चाहिँ मैले केही प्रोग्रामहरु डिजाइन गरिरहेको छु। मसँग एउटा यो कम्फर्टर छ। यो भनेको के हो भने यो चाहिँ चिया कफी राख्ने एउटा प्लेट जस्तो हो र यो चाहिँ वुडबाट बनेको छ। एकातिरको सतह चाहिँ चिल्लो छ, अर्कोतिरको सतह चाहिँ खस्रो छ हैन। this surface is rough and this surface is smooth. Okay, so if you have this kind of object with you right now, you can repeat the experiment. If you don't want to repeat the experiment now, you can do the experiment later. Okay, so as I mentioned in the last class and also advertised, we will be investigating Newton's laws of motion. We are trying to learn Newton's laws of motion. Newton in 1686 published Principia, a book. Right, Newton was a scientist, a greatest scientist of all time. Right, he did so many works in physics, in maths, right, in about nature, about philosophy, natural philosophy. Right, so let me do one quick experiment with this comforter. Okay, so it has a smooth surface on one side and it has a rough surface on the other side. Okay, so I have a finitely long table. I am doing in my dining room. In my living room. The table is small. So let me push this. Please watch. I have this computer. So I am pushing from the rough side. Okay, right. So it moved to a small distance. Let me move one more time. It moved a small distance. Let me apply the same amount of force and then push this on the smoother side. So let me push it. So it almost hit my smartphone, right? So it went farther. So let me push one more time. Okay, it went farther. Let me push one more time. It moved farther on the rough surface. Let me push one more time. So it stopped relatively at a closer distance. Okay, now I will give you 1 minute to think about this. Why did that happen so? Okay, so students, please think about this. When I moved this comforter on the table on the same surface, right? From putting this smoother surface in contact with the top of the table, it moved a longer distance. So on the other hand, when I use this rough surface, it moved to a certain distance. It stopped at a certain distance. Now, why? Please think about that. Okay, you guys can do this experiment. Everyone can do this experiment. This is a very simple experiment. I am doing experiments with the equipments, whatever I have available around me in my living room or kitchen or dining room, like that, in bedroom, like that. Okay, so please think about it for a minute. Why? यो कम्प्युटर चाहिँ मैले स्मुथ साइडमा चाहिँ टेबलमाथि पुश गर्दाखेरि फार्दर डिस्टेन्स गयो, तर रफ सर्फेसमा मैले पुश गर्दा चाहिँ सर्टर डिस्टेन्समा स्टप भयो. किन? यो तपाईहरुले चाहिँ थिंक गर्नुस् त एकपटक. तपाई you can discuss if you are with your parents, your teachers, please discuss why is that. This is a very fundamental law of physics, right? तपाईहरु त्यसमा डिस्कस गरिरहनु भएको छ अथवा थिंक गरिरहनु भएको छ भने that's great. I love that. Okay, please do that. Think. Never stop questioning. That's what Albert Einstein said. Never stop questioning. Please ask, why did that happen so? Okay, why did this smooth surface, when I put the smooth surface of the computer and pushed, it went farther, and the rough surface on the same table, then it stopped in a short distance. Why? Ask this question. Okay, see, this has a historically important connection. This was the experiment done by Galileo Galilei. Okay, this simple experiment was done by Galileo Galilei. What did he do? He pushed an object on a surface, and he observed that it moved to a certain distance. Then what did he do? He made the surface smoother. He pushed again. What did he observe? The object moved to a further distance, bigger distance, greater distance. He moved smoother. What did he do? He pushed again the object, and he observed that it moved to a greater distance. From these very simple experiments, he concluded that any object in the absence of external force will continue moving forever. It will not stop if there is no external force. If there is no external force, if an object is at motion, it will be moving forever. Okay? And if it is at rest, for example, if I put this computer on the top of the table, it will be there forever if I don't apply external force. So that is the Newton's first law of motion. We also call this Galileo's law of inertia. Okay? Inertness. What is inertia? Inertia means inertness. An object itself is inert. An object itself is inactive. An object itself doesn't move by itself. An object itself doesn't come to rest by itself. Okay? So what should we do? We need to apply a force. Right? What does the force do? An object which is at rest, right, is moved, is brought to motion. So when a moving object is moving, you apply force, so it will be stopped. So what is external force? So that is actually the definition of force. Force is something like push or pull. Force is like something which is in the form of push or pull, right? So that causes the change of state of an object. If an object is at rest, it will remain at rest. If an object is moving, it will be moving. Until when? Until there is unless you apply an external force. Once you apply the force, the force can stop the object. If you apply the force on an object at rest, what will happen? The object will come to motion. That might come to motion. There should be enough force. Okay? So this is the Newton's first law of motion. Right? So Newton's first law of motion is actually a summary of Galileo's law of inertia. If an object is at rest, it will remain at rest. That is called inertia of rest. Inertia. So if you are students, please write this word. I am spelling the word. Inertia. 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 Okay? So inertia of rest. If an object is at rest, it will remain at rest. If an object is moving, it will be moving. Right? So when the object is moving, it keeps on moving. That is inertia of motion. The same word. Inertia. Inertia of motion. What is that? Inertia of motion. What does that mean? If an object is in motion, if an object is moving, it will keep on moving forever unless there is an external force. That's Newton's first law of motion. See, that's a very simple thing, but this is so powerful. Right? You may not appreciate this law until you apply this in problems. When you start solving problem, and that will click in your mind. Oh, that is the Newton's first law of motion. That is law of inertia. That is inertia of rest. That is inertia of motion. Okay? I hope this clarifies Newton's first law of motion. So I'll come back and give more example on Newton's first law of motion. Okay? But let me do a different experiment. Okay? So a slightly different experiment. Okay? So I have this book in my hand. Okay? Please don't worry what is the name of the book. I can tell you, Introduction to Electrodynamics. Right? It is undergraduate textbook. So I have this textbook in my hand. Right? I put this book on the surface. So what do? I apply. See, I cannot do the experiment quantitatively because I don't have all these instruments to measure the force. But I am explaining you qualitatively. Okay? So this object is on the top of the table. So what do? I push it. Right? With certain force. Right? So the object is moving. See? The object is moving. When I push, means I am applying force. Now every one of you be comfortable to understand what force is. Right? What does force do? What does force do? What does force do? Force can bring the object to motion. Right? So that's what it is happening here. See? The object is here on the top of the table. I am pushing it. It is in motion. Right? So instead of one, let me put two objects. Now I have another book. I also teach astrophysics. So this is also undergraduate textbook. It is of the same size. I chose books of almost the same size. Right? So I put now on top of that. So I try to apply the same amount of force as I did before. Right? So it is very difficult to move. See? Very difficult to move. I almost applied the same amount of force. I can, of course, I haven't measured the force exactly, but it is very difficult to move. Right? So let me put some bigger book on top of that. Okay? So I have another book. Okay? Slightly, almost the same size. And this is, by the way, this is a graduate textbook taught to masters and PhD students, classical electrodynamics. So which is of the same size. So let me put here. Now let me try to apply the same amount of force. Okay? I can hardly move this books of a combination of three books. Right? So what is happening here? Let's try to understand. So these three books have approximately the same mass. यो तीनटा बुकको एप्रोक्सिमेटली मास उति नै छ भनेको यसको स्लाइटली बढी होला यसको अलिकति कम छ र यसको अलिक कम छ होला राइट दे हैव सेम अमाउन्ट अफ मास व्हाट इज मास मैले हिजो तपाईहरुलाई भनेको थिए अस्तिको हप्ता मलाई तपाईहरुलाई भनेको थिए आई टोल्ड यु मास इज मेजर्ड इन किलोग्राम or grams. And do you remember? Try to recall. What is the mass of this apple? It is average sized apple. Can you please tell me what is the mass of this apple? You cannot, because we are not doing, it is a kind of one-way flow from me to you, right? But you can write in the comment, what is the mass of this? Okay, what is the mass of this? Did any of you write? What is the mass of this? Okay, if you forget, don't worry, okay? You can ask your parents or whatever, or teachers, right? So I told you guys last time, right, in my last episode. So this apple has mass of about 100 grams. So 100 gram means what? 100 grams is how much? 100 divided by 1000, so it is about a tenth of a kilogram. A tenth of a kilogram, which is 0.1 kilogram, right? So that is the mass, right? So when I drop it, it goes down because the earth pulls this downward. With what force? Do you recall? How much is that force? You forgot? Please don't worry. If you remember, please tell me, right? How much is that? You please write in the comment. Okay? The force is, right? The force is about 1 Newton, right? So just like that, I am pushing these objects with force. I don't know how much exactly I applied the force, but I tried to apply the same amount of force in all 3 cases. With 1 book, with 2 books, with 3 books on top of each other, right? So what did I do? What I am doing here? I am increasing mass. Mass of 1 book, let's say maybe about 1 kilogram. Mass of the other book, let's say about 1 plus 1, 2 kilograms. Mass of the third book, let's say 1 plus 1 is 3 kilograms. I haven't measured exactly. These books are slightly heavier, by the way, right? So 3 kilograms, right? So when I apply the same amount of force, right? Same amount of force, right? So it moves faster, right? When I apply for the two objects, right? It does not move that fast as previous, right? When I apply 3 objects, put 3 objects, I am increasing the mass. So, right? So it is very slow. What does that mean? What does that mean? Let's try to understand. What does that mean? I am increasing the mass. I am applying the same amount of force. I am increasing the mass. I am making the objects heavier and heavier, more and more objects, right, on top of each other, right? Please don't do like this. Push one mass and the same other mass separately, and push the same mass separately. Please don't do that. Please keep on top of each other, and on top of each other. Then keep increasing that will increase the mass of that combination. Then what will happen? So once you increase the mass, the combination of the mass is not moving as fast. So what does that tell us? Is acceleration. Acceleration. A-C-C-E-L-E-R-A-T-I-O-N. Acceleration. So acceleration is inversely proportional to mass. What does that mean? If you increase the mass, acceleration will go down. If you keep the same force, I tried to maintain the same amount of force. I tried to create the same amount of force. I tried to adjust the same amount of force. Okay? I don't exactly know how much force, but I tried to push with the same amount of force. Right? So what does that mean? Let's try to understand. When you increase the mass of an object, right? Combination of objects in our case, right? Apply the same force, acceleration will go down. That means the object cannot move that fast. The object cannot start with that fast pace. That is connected with acceleration. नेपालीमा भन्न चाहनुहुन्छ त्यसलाई प्रवेग भन्छ. मैले के गरेँ? मैले यहाँ पिण्ड मास बढाउँदै गएँ. धेरै मास बनाएँ तर त्यही फोर्स लगाएँ, त्यही बल लगाएँ. धेरै मास बनाएँ तर त्यही बल लगाएँ. अब्जेक्ट चाहिँ छिटो स्टार्ट गरेन. स्लोली स्टार्ट गर्यो. धेरै मास हुँदाखेरि, थोरै मास हुँदाखेरि फास्ट गयो. यसलाई चाहिँ हामीले के भन्छौँ? न्युटन्स सेकेन्ड लको एउटा फर्म, न्युटन्स सेकेन्ड लको एउटा पार्ट हो. न्युटनको चाल सम्बन्धी दोस्रो नियम, न्युटन सेकेन्ड ल अफ मोसन. अब त्यसको सट्टा यस्तो गरौँ. मसँग एउटा मात्रै अब्जेक्ट छ, मैले मास कन्स्टेन्ट राख्छु. म चेन्ज गर्दिनँ यसलाई. म यही अब्जेक्ट मात्रै राख्छु. म बिस्तारो थोरै फोर्सले पुस गर्छु. इट इज मुभिङ स्लोली, राइट? अनि म के गर्छु? अलमोस्ट डबल फोर्स गर्छु, लाइक द्याट. फास्ट मुभ गरेँ. अनि म अझै बढी फोर्स लगाउँछु, लाइक द्याट. आई अलमोस्ट हिट माई स्मार्टफोन. ओके, सो मैले के गरेँ? यो अहिलेको एक्सपेरिमेन्ट मैले के गरेँ? मास कन्स्टेन्ट राखेँ. वाट डज द्याट मिन? मैले मास कन्स्टेन्ट राखेँ भनेको के हो? सोच्नुहोस् त, 1 मिनट थिङ्क गर्नुहोस् त. प्लिज थिङ्क अबाउट इट 1 मिनट. I kept mass constant. What does that mean? Could you please think about that? Let me give you think for a minute. I kept mass constant means I didn't change the size of the book. I didn't add books. I have this book in my hand. That's it. Right? I didn't change that. Right? So I kept the mass constant means I am using the same mass. Right? But what did I do? in one case, I pushed gently, right? In the second case, I pushed with a little bit more force. In the third case, I applied really more force, right? Really high force, right? So what did I observe? What did I observe? When I applied more and more force, the object was moving faster and faster. So what does this tell us? So if mass is kept constant, okay, please keep in mind, if mass is kept constant, so when you apply more and more force, acceleration is more and more. That is another part of Newton's second law. Okay, I'll summarize that, don't worry. Okay, so what is Newton's second law? What is Newton's second law? Let's recall. In the first case, what did we do? We changed the mass. In the second case, what did we do? We kept the mass constant, right? And we changed the force. Make sense? I hope you guys are following me, right? If you are parents, if you are teachers, please help the students, okay? I really appreciate that, okay? Because this is our joint effort to make our kids the future stars, okay? So, what I am doing today, Newton's laws of motion. We are talking about now? Newton's second law of motion. So in the Newton's second law of motion, I did two simple experiments. What did I do? In one case, I increased the mass, but I kept the force same. Right? And what I observed? I observed the motion. That motion is related to what? Acceleration. That motion is related to what? Acceleration. Right? That is a difficult term for a smaller student of lower grades. One of my students commented, I love that comment, thank you so much, that I taught her back several years ago in Little Angels, right? And she said that my daughter understood most of the things, Rudra sir, but one thing was difficult for her, acceleration. Of course, acceleration is not easy. Acceleration is difficult. It is not easy to understand. Even Albert Einstein did very hard work to understand that. That's how he came up with the theory of relativity. Okay? So, what I'm saying here, in Newton's second law, there are three things. Keep in mind. Mass, force. What is the next? What was that next? Anyone? Could you please comment at the bottom? What was that? Mass, force, and acceleration. We have three quantities, right? Mass, force, and acceleration. Those three quantities are related by a beautiful equation, F equal to ma. Could you please write, if you have pen and paper handy, please write this equation. Excuse me. Please write that equation. F means force. And please don't forget to give arrow on the head of force. F equal to m times acceleration. Please give arrow on top of force and on top of acceleration. Please don't give arrow on top of mass. Okay, please don't give arrow on top of mass. Let me tell you quickly, any quantities which are written with arrow on the head are called vectors. So force is a vector. So force is a vector quantity. What is a vector quantity? A vector quantity has both magnitude, means its value, and direction. So that arrow is important. Please don't forget the arrow. Okay, guys? Okay, if you are little children, okay, I will be unhappy if you forget arrow. Okay, please don't forget arrow on top of force. That is important. Yeah, good. Somebody has already written there. And I think somebody missed the arrow on top of acceleration. Please don't do that. Please write arrow on top of force. Write arrow on top of acceleration. So force is equal to mass times acceleration. Please don't write arrow on top of mass, m. No. Why? Because mass is a scalar quantity. Mass is a scalar quantity. Mass has only magnitude. Length has magnitude only. Time has magnitude only. For example, I am staying with you, all of you, for 1 hour. हजुरहरुसँग म 1 घण्टा मात्रै बसिरहेको छु. 1 hour time. It doesn't have direction. You might be confused. Oh, time has direction. Time always follows forward. Don't worry about that. That's a different thing. Okay? So let me summarize Newton's second law of motion. So Newton's second law of motion le ke bhancha हामीलाई? Newton's second law of motion le ke bhancha? Force equal to ma. Capital F, arrow on top, is equal to mass times acceleration. That is the equation. So let me tell you in sentences. Acceleration is directly proportional to the force when mass is kept constant. Acceleration is directly proportional to the force applied when mass is kept constant. You don't change mass. You remember I did experiment? I did only experiment with only one book, but I applied force, different amount of force in different time. Make sense? Okay? So in the other case, acceleration is inversely proportional to mass when force is kept constant. Right? What did I do? I used 3 books. Book number 1, book number 2, book number 3, and I combined them, making a big mass, big block of books, right? Big stack of books, and I applied the same amount of force. When I increased the mass, the motion was not that fast. Okay? So if I apply the same force with this giant book on top of that, oh yeah, now it can hardly move. It can hardly move. I am applying force, see, already, but it is not moving. It is not. Why? The reason is there is too much mass. Can I move it? Of course I can if I need to apply more force. But that's not my goal. My goal is to look at Newton's second law. So I wanted to increase the mass. I wanted to change the mass, keeping the force constant. Okay, that is Newton's second law. That is Newton's second law of motion. Let's consider some practical example in everyday life. Okay, अब नेपालमा चाहिँ रेनी सिजन आउँदैछ. हाम्रा गाउँघरका बाटाहरू चाहिँ के छन्? हिलाममै छन्. हो कि हैन त? हैन? हजुरहरूले देखिरहनु भएको छ, एक्सपिरियन्स गरिरहनु भएको छ. हाम्रा गाउँघरका बाटाहरू के छन् त? हिलाममै छन्. हैन? अनि त्यस्तो त्यो गाउँघरको बाटोमा इन द रोड्स, muddy roads, suppose there is a bus stock, there is a car stock, there is a motorcycle stock, there is a bicycle stock. Okay, I am giving 4 examples. There is a bus चाहिँ हिलोमा फस्यो. Bus is stuck in muddy road. Car is stuck in muddy road. Right? What is the third one? Motorcycle stuck in muddy road. What is the fourth one? What? Bicycle. Right? So अब तपाईहरुले के गर्नु पर्यो? अब तपाईहरुले के गर्नु पर्यो? तपाईहरुले के गर्नु पर्यो भने तिनीलाई घचेडेर निकाल्नु पर्यो. ओके? अब घचेडेर निकाल्नु पर्यो. अब घचेडेर निकाल्नु पर्यो. तर त्यही एउटै फोर्स, त्यही अमाउन्ट अफ फोर्स लाउनुस् त. त्यही अमाउन्ट अफ फोर्स मानौ एकजनाले बाइसिकल तान्यो. के हुन्छ? बाइसिकल इजिली निस्किन्छ. किन? Why? Can you please write comment? किन बाइसिकल सजिलै निस्किन्छ? Because bicycle has a smaller mass. Why? Bicycle has a smaller mass. Okay, त्यही फोर्स लाउनु भयो भने excuse me, bicycle has a smaller mass. Okay? अब मोटरसाइकल कुरा हेर्नुस्. एकजना मान्छेले तान्यो, उले हार्डली निकाल्न सक्ला. किन? Why? त्यही फोर्स लगायो, त्यही मान्छेले तान्यो. जो मान्छेले बाइसिकल तान्यो थियो त्यति नै फोर्स लगाएर, कल्पना गर्नुस् कि त्यति नै फोर्स लगाएर मोटरसाइकल तान्यो. निकाल्न सक्छ उले? इट माइट बी डिफिकल्ट. अब कार तानेको कुरा हेर्नुस् न. कार घचेडेको कुरा हेर्नुस् त. इट इज इम्पोसिबल. वाइ? कार माइट ह्याभ लार्ज मास. हैन? हो कि हैन त? अब त्यसको सट्टा तपाईहरुले बसको कुरा हेर्नुस् त. इट इज इम्पोसिबल. उही झिङ्गाले गाडी हाने जस्तो मात्रै हो. झिङ्गाले गाडीमा हिर्कायो भने के हुन्छ? गाडी मुभ गर्छ? गर्दैन. धेरै मान्छेहरू लगाएर, धेरै फोर्स लगाएर मात्रै चाहिँ हामी बसलाई तान्न सक्छौँ बाहिर हिलोबाट. भनेपछि बढी फोर्स लाउनु पर्यो. हामीले किन साइकल सजिलैसँग निकाल्न सकिने, मोटरसाइकल अलिक गाह्रो हुने, कार धेरै गाह्रो हुने, बस त्यति नै फोर्स लाउँदा निकाल्नै नसकिने कारण के हो त भन्दाखेरि मास इन्क्रिज भइरहेछ. त्यही फोर्स लगाएर काम गर्दैन. द्याट इज द एप्लिकेसन अफ न्युटन सेकेन्ड ल. That is the Newton's application of Newton's second law. एउटा एप्लिकेसन थियो. अब अर्को कुरा हेरौँ न. त सपोज एउटा फुटबल छ. तपाईहरु फुटबल प्रेमी हुनुहुन्छ होला हैन? एउटा फुटबलको कुरा हेर्नुस् र तपाईको सानो भाइलाई फुटबल किक गर भन्नुस् त. त्यो फुटबलमा चाहिँ अलिकति मुभ गर्ला हैन? अनि तपाईले बेसरी हिर्काउनुस् त. तपाईले बडी फोर्सले हिर्काउनुस् त. के हुन्छ हेर्नुस् तपाईले मास त कन्स्टेन्ट छ नि यहाँ त. मास इज कन्स्टेन्ट. किन? द मास अफ द फुटबलको मास कति किलोग्राम होला हैन? यो मतलब एउटा फिक्स मास छ. अब तपाईको सानो भाइले खुट्टाले बिस्तारो हिर्कायो भने त्यो एउटा सर्टेन डिस्टेन्समा जान्छ. अब झाडी नजाला, कति फोर्स लाउँछ, अलिकति रोल होला. तर तपाईले अलिकति बल लगाएर किक गर्नुस् त, त्यो अलिक पर जान्छ. तपाईभन्दा ठुलो मान्छे लाइक पेलेको कुरा हेर्नुस् त, अथवा रोनाल्डोको कुरा हेर्नुस् त, अथवा हाम्रै नेपालकै फुटबल प्लेयर साथीहरूको कुरा हेर्नुस् त. उहाँले बेसरी किक गर्नु कहाँ हुन्छ? कहाँ पुग्छ हैन? किन? मोर फोर्स फर द सेम मास, सो हायर एक्सेलरेसन. एक्सेलरेसन गाह्रो कुरा हो. तपाईहरु चिन्ता नगर्नुस् अहिले. यो क्लासै यो त इट इज बिगिनिङ अफ लर्निङ. I will be coming with you. If you are liking me, if you are liking my class, if this class is helping you, if this class is making you happy, I will be coming every Saturday. Okay? So, we will be learning. Please don't worry. Okay? This is the start. Okay? Now, हामीले दुईटा लजहरु पढ्यौं है. फेरि म तपाईलाई रिमाइन्ड गर्छु नि, बिर्सिनु भयो कि के अरे फर्स्ट ल अफ मोसन हैन? फर्स्ट ल अफ मोसन त्यसले के भन्छ अरे? An object at rest remains at rest. An object at rest remains at rest unless you apply external force. A moving object keeps on moving unless an external force is applied on it to stop it. That's the first law of motion. Actually, त्यसले force भनेको के हो भनेर define गरिदिन्छ. This is the definition of force. It defines force के हो त? What is force? Force भनेको त push र pull. जसले object रेस्टमा छ भने मोसनमा ल्याइदिन्छ, मोसनमा छ भने रेस्टमा ल्याइदिन्छ. त्यति मात्र हैन, अरु कुरा पनि फोर्सले गर्छ. तर बेसिकली फर्स्ट लले त्यो भन्छ. सेकेन्ड लले के भन्छ? How much is the force? How much is the force? If I know mass, if I know acceleration, if I multiply, F equal to ma. That's the force. So यसले force नाप्छ. It measures force. What does it do? What does it do? What does it do? It measures force. It measures force. It is the measurement of force. F equal to ma. तर F equal to ma ले नि सबै कुरा बुझ्नलाई गाह्रो हुन्छ. जस्तै तपाई रकेट प्रक्षेपणको कुरा गर्नुभयो भने न्युटनको ललाई न्युटनले ओरिजिनली जे भनेका थिए त्यसरी गर्नुपर्छ. हामी अर्को क्लासमा कुरा गरौँला नि है त. त्यसको विषयमा हामी अर्को क्लासमा कुरा गरौँला. तपाईले इन्जोय गरिराख्नु भएको छ कि? आर यु इन्जोयिङ अर यु आर फिलिङ बोर्ड? Are you enjoying? Hello? Okay, good. I hope you are enjoying. Good. Thank you. Okay? Thank you so much. Okay, so here, what I am saying, Newton's second law of motion, जुन F equal to ma भने नि मैले, त्यो सबै ठाउँमा त्यसले मात्रै काम गर्न सक्दैन. जस्तै रकेट फ्लाई गर्दाखेरि, हामीले रकेट प्रक्षेपण गर्दाखेरि, if you are launching rocket, it might not work. Okay? So न्युटनको ललाई हामीले न्युटनले ओरिजिनली जे भनेका थिए त्यो फर्ममा राख्नुपर्छ. F equal to ma मात्रै राखेर हुँदैन. अहिले चिन्ता नगर्नुस्, म I will talk about that in future. Okay, that's the second thing. अनि जस्तै रेनफल भइरहेछ, रेन ड्रप्सहरु फर्म भइरहेछ क्लाउडमा भने पनि F equal to ma ले काम गर्दैन. हामीले के गर्नुपर्छ? हामीले स्लाइटली डिफरेन्ट फर्ममा न्युटन सेकेन्ड ललाई राख्नुपर्छ. ओके, अब हामीसँग बाँकी के रह्यो? न्युटनको तीनटा लजहरु छ. फर्स्ट ल सजिलो छ, नाम सजिलो छ नि. फर्स्ट ल, पहिलो नियम, न्युटन्स फर्स्ट ल अफ मोसन, न्युटन सेकेन्ड ल अफ मोसन. What is left? First, second, what is left? What? Third law. First law, second law, third law. So, third law के हो त? थर्ड ल के हो? म तपाईलाई एउटा डेमो गर्न जाँदैछु. मेरो छोरोको एउटा गुडिया भेटाएँ मैले. एउटा छोरोको गुडिया रहेछ. अनि मैले हिजो बेलुका यसो थिंक गरेँ, विचार गरेँ, can I use this in my demo? अनि उसलाई सोधेँ. ओके, उसले भन्यो of course you can. अनि मैले यसो थिङ्क गरेँ क्यान आई युज टु डेमोन्स्ट्रेट सम लज अफ मोसन र मैले ट्राई गरेँ एकछिन इट वर्कड राइट सो लेट मी सो यु द डेमो राइट तपाईँले देख्नु भएको छ यो गुडिया राइट यसको माथि एउटा टाउको छ यस्तो राइट विच आई क्यान डिट्याच राइट सो लेट मी नट डिट्याच बिकज दिस गाई इज रियली ह्याप्पी ओके सो लेट मी पुट इट ब्याक हियर ओके हेर्नुहोस् त यो गुडिया अब यस्तो छ यहाँ हेर्नुहोस् है तपाईँले देख्न सक्नुहुन्छ कि सक्नुहुन्न मेरो क्यामेराको पोजिसनले गर्दाखेरि लेट मी ट्राई माई बेस्ट वाट डु आई डोन्ट किक इट वाट डु आई डु प्लिज वाच आई पुस इट डाउन के भयो अब हेर्नुहोस् है आई पुस इट डाउन एन्ड इट फेल on the table. Let me repeat, okay? It is very interesting. Let me do one more time. है त म फेरि एकपल्ट गर्छु है त मैले यहाँ हेर्नुहोस् है मैले अरू के गरेको छैन देयर इज नो म्याजिक आई एम टिचिङ यु फिजिक्स प्लिज थिङ्क द्याट वे ओके इट इज नट म्याजिक इट इज फिजिक्स आई एम टिचिङ यु फिजिक्स सो प्लिज थिङ्क फिजिक्स वे ओके सो what I am doing here, I am pushing it down. See, please watch. I am pushing vertically down. Okay, let me release it. It falls. Okay, it falls. Why is that? यो चाहिँ हामीले यसलाई न्युटन्स थर्ड ल अफ मोसन अनुसार एक्सप्लेन गर्न सक्छौँ न्युटनको तेस्रो चाल सम्बन्धी तेस्रो नियम न्युटन्स थर्ड ल अफ मोसन वाट डज इट टेल अस टु एभ्री एक्सन there is equal but opposite reaction. To every action, there is equal but opposite reaction. हरेक क्रियामा बराबर तर विपरीत प्रतिक्रिया हुन्छ. To every action, there is equal but opposite reaction. हरेक क्रियामा के हुन्छ बराबर तर विपरीत प्रतिक्रिया हुन्छ हैन अब हेरौँ त यसलाई कसरी एक्सप्लेन गर्ने मैले के गरेँ यो टेबल माथि छ हेर्नुहोस् है यसलाई एक्सप्लेन गरौँ है त यो टेबल माथि छ मैले पुस गरेँ मैले पुस गर्दा के गरेँ त्यहाँ स्प्रिङ छ भित्र लेट मी नट ब्रेक इट देयर इज अ स्प्रिङ इनसाइड ओके आई कम्प्रेस द्याट स्प्रिङ मेक सेन्स आई कम्प्रेस द्याट स्प्रिङ आई क्यानट मेजर द्याट बिकज इट डजन्ट ह्याभ measuring device, but there is a spring and I compress that with certain force. Make sense? And then let me release it. So what happens? तो के हुन्छ त्यो स्प्रिङलाई मैले कम्प्रेस गरेको थिएँ थिचेर अनि त्यो स्प्रिङले चाहिँ यो माथिको अब्जेक्टलाई चाहिँ के गर्यो माथि फाल्दियो त्यसले यो अब्जेक्टले चाहिँ त्यो स्प्रिङ माथि जाँदाखेरि त्यो स्प्रिङले चाहिँ इक्वल बट अपोजिट रियाक्सन कसलाई दियो यसलाई दियो हैन तपाईले भन्न सक्नुहुन्छ इज इट इक्वल अर नट इक्वल अफ कोर्स यु क्यान अलवेज आस्क द्याट क्वेसन आई हेभन्ट मेजर्ड इट बट हामीले स्प्रिङ ब्यालेन्स राखेर चाहिँ नापेर हेर्ने भने दे आर इक्वल विल फाइन्ड देम इक्वल राइट अनि के हुन्छ त्यसले गर्दाखेरि यसलाई फोर्स दियो यसले यो त टेबलमाथि अडिया छ यसले टेबललाई डाउनवर्ड पुस गर्यो अनि टेबलले के गर्यो यसलाई अपवर्ड पुस गर्यो टेबलले अपवर्ड पुस गर्यो राइट लेट्स रिपिट वान मोर टाइम टेबलले अपवर्ड पुस गर्यो अनि यो के हुन्छ यसको वेट चाहिँ माथितिर हेभी भएकोले ब्यालेन्स गर्न सकेन र ढल्यो द्याट इज न्युटन थर्ड ल अफ मोसन वाट इज न्युटन थर्ड ल अफ मोसन टु एभ्री एक्सन देयर इज इक्वल बट अपोजिट रियाक्सन लेट मी रिपिट टु एभ्री एक्सन देयर इज इक्वल बट अपोजिट रियाक्सन ओके एक्सन द फोर्स यु गेभ रियाक्सन द फोर्स अब्जेक्ट गिभ्स यु होइन तपाईँ यसरी तपाईँलाई साह्रै अल्छी लाग्यो म आराम गर्छु भनेर यसरी बसिराख्नुहोस् त वाट ह्यापन्स यु आर पुसिङ बाई योर एल्बो यु आर पुसिङ द टप अफ द टेबल डाउनवर्ड इज द राइट वाट आर यु डुइङ यु आर पुसिङ द टेबल डाउनवर्ड द्याट्स द एक्सन वाट इज द टेबल डु इट इज गिभिङ रियाक्सन टेबलले तपाईँलाई बल दिँदैन त्यसले फोर्स दिँदैन भनेर नसोच्नुहोस् दिन्छ त्यही भएर त लङ टाइम तपाईँ पुस गरिरहनु भयो कस्तो हुन्छ दुख्छ नि दुख्छ इट बिकज द टेबल इज पुसिङ यु अप द्याट्स द रियाक्सन फोर्स मैले एउटा प्रश्न राखेको थिएँ 1-2 दिन अगाडि फेसबुकमा म बेला बेलामा त्यस्ता सानातिना प्रश्नहरू राखिरहने गर्छु दे आर इम्पोर्टेन्ट प्लिज थिङ्क अबाउट दोज क्वेसन्स म युजुअली नेपालीमा पोस्ट गर्छु, बुझ्न तपाईँहरू सक्नुहुन्न नेपालीमा शब्दहरू बुझ्नु भन्नु भने प्लिज आस्क योर पेरेन्ट्स, प्लिज आस्क योर टिचर्स. It is their responsibility to explain those kind of questions to you. If they don't know the answer, that's fine. Please don't worry. Think about that. सबै क्वेसनको एन्सर जान्नुपर्छ भन्ने छैन, तर बिस्तारै बिस्तारै जान्ने प्रयास गर्नुपर्छ, सिक्नुपर्छ, सिक्न खोज्नुपर्छ. तर तपाईँ उहाँहरूलाई डेफिनेटली तपाईँहरूलाई चाहिँ बालबालिकाहरूलाई चाहिँ तपाईँहरूको क्वेसनको उत्तर दिने प्रयास त गर्नुहुन्छ डेफिनेटली. ओके, द्याट्स everyone's responsibility. That is my responsibility. I thought, why I'm running this program? I thought I can share my knowledge with you. I can explain things. I can explain the concepts. Okay, what are your teachers doing in school? They are doing the same thing. They are explaining things to you. They are motivating you. They are inspiring you. What are the parents doing? They are supporting you. Okay, so see, a child's education is a tripartite effort. What is that? Yourself. The first is yourself. तपाईहरु आफै प्रयास गर्नुस्. I can do, I want to do, I want to learn first. तपाईहरु आफै प्रयास गर्नुस् first. तपाईहरु प्रयास गर्नु भने हुँदैन. भनिन्छ नि, बिरामीले औषधि खाएन भने बिरामी निको हुन्छ, हुँदैन. त्यही त पहिलो कुरा तपाईहरु आफै प्रयास गर्नुस्. First, try yourself. Try yourself. Second, take help from parents. Second, third, take help from teachers. So this is a triangle, triangular effort. म कहिलेकाहीँ मेरो छोरोलाई सोध्छु, do you need any help? No, he says that, no, I'm trying. Okay, good. I'm trying, good. Right? And कहिलेकाहीँ मैले उलाई भनौँ न, धेरै बेरसम्म थिङ्क गरिरहेको हुन्छ अनि can I help you? No, Baba, I'm thinking. That's the way you need to think. That's the way you need to do. First, you need to make effort. First, you need to try. First, you need to have a kind of initiation, a kind of, I want to do. And then my lecture will help. And then your parent support will help. And then your teacher support will help. We all are here in this world to help you. Okay? Now, let's come back to our Newton's laws of motion again. How many laws of motion? First law of motion, second law of motion, third law of motion. Right? Third law of motion, to every action there is equal but opposite reaction. Harek kriyama action, action is a force. When there is a force, there is a reacting force. अब Newton's third law of motion को application कहाँ हुन्छ त? एक दुईवटा एक्जाम्पलहरु सोचौं. Let's think about that. Right? Let's think about that. So one immediate example, I already showed you, demonstration of a simple. You don't need to think, have very state-of-the-art gadgets. If you have, that's great. अहिलेको साइन्स एन्ड टेक्नोलोजीको डेभलपमेन्टले गर्दा तपाईसँग राम्रा राम्रा सामानहरू छन्, मतलब एकदम हाई क्वालिटीका इक्विपमेन्ट छन्, that's fine. But see, I have a ball pen in my hand. You see? It's a ball pen in my hand. हेर्नुस् त, यो बल पेन यहाँ अहिले यो बल पेन लेख्ने चाहिँ देखिया छैन नि. म के गर्छु? प्रेस गर्छु. हेर्नुस् त, यहाँ लेख्ने कुरा आयो. The nib आयो, nib. Right? We can write that, right? With this, we can write with this. अब फेरि तपाईले प्रेस गर्नुस् त, it goes inside. Why? There is Newton's third law of motion. How can you say that? How can you say that? Because, right, what happens? There is spring. When you press it, there is a force downward. When you press again, right, the spring now, like what does it do? Pushes back. Okay, now spring has the force. The spring exerts the force. Right? Okay? So let's think something else. Okay, let's think something else. म चाहिँ उस्टर पोलिटेक्निक इन्स्टिट्युट युनिभर्सिटीमा पढाउँछु फिजिक्स. This is in Worcester, Massachusetts. Okay, in the state of Massachusetts. र त्यो युनिभर्सिटीसँग जोडिएको एउटा एकदमै इम्पोर्टेन्ट एक्जाम्पल तपाईहरुलाई दिन चाहन्छु. रबर्ट गडर्ड. तपाईहरुले नाम सुन्नुभएको होला रबर्ट गडर्ड. He was the pioneer of rocketry. Okay, liquid fuel rocket को पहिलो टेस्ट रबर्ट गोडर्डले गरेका थिए. यही नजिकै म बसेको ठाउँबाट अलिक टाढा अर्बन भन्ने ठाउँमा. उनले चाहिँ सन् 1908 मा WPI बाट ब्याचलर डिग्री गरेका थिए. उनले लेखेको थीसिस अझै पनि हाम्रो फिजिक्स लाइब्रेरीमा छ WPI-मा। उनले त्यो रकेटको टेस्ट गर्दाखेरि बेसिक प्रिन्सिपल न्युटन थर्ड ल युज गरेका थिए, because that's the law. But he saw that this law works in rocket. This law works in rocket. That's he saw that. अनि उनले के गरे, उनले चाहिँ लिक्विड फ्युल रकेट टेस्ट गरे, इट वर्कड। त्यतिखेरका पत्रिकाहरूले, केही पत्रिकाहरूले यस्तो हुन सक्दैन, जब ग-२ले रकेट चाहिँ स्पेसमा जान सक्छ, भ्याक्युममा पनि ट्राभल गर्न सक्छ, न्युटन थर्ड लको कारणले गर्दाखेरि यसमा चाहिँ त्यो बन्ड फ्युल र ग्यासेसहरू चाहिँ तलतिर सुट गर्यो, त्यति नै एमाउन्ट अफ फोर्स चाहिँ रकेटलाई दिन्छ अनि रकेट चाहिँ स्पेसमा जान सक्छ, भ्याक्युममा जान सक्छ भन्दा तत्कालीन केही पत्रिकाहरूले चाहिँ इट क्यानट ह्यापन, इट इज नट पोसिबल भनेर चाहिँ उनीहरूले पत्रिकाहरूले लेखेका रेकर्डहरू तपाईँले गुगल गर्नुहोस्, इन्टरनेटमा तपाईँ पाउन सक्नुहुन्छ। भेरी फेमस जर्नल्स, लेट मी नट नेम हियर, राइट। अनि जब पछि रकेटहरू टेस्ट गरिए, रकेटहरू स्पेसमा गए, देन द जर्नल्स retracted that article. What does that mean? Sorry, we were wrong. Goddard's thought was right. Yes, it could work. That's how the rockets are now. These are everyday missions. Everyday rockets are sent to space from all over, from different countries to the space. That's Newton's third law of motion. To every action, there is equal but opposite reaction. हामीले न्युटन्सका लजहरू, फर्स्ट सेकेन्ड थर्ड तिनटै लजहरू लगाएर रकेटको मोसनलाई हामी एक्सप्लेन गर्न सक्छौँ। तर मैले सेकेन्ड लमा F=ma भने जुन, त्यो मात्रै चाहिँ सम्भव छैन है, त्यसलाई अलिकति हामीले फरक ढङ्गले त्यसलाई एक्सप्लेन गर्नुपर्छ। अब न्युटन्सको थर्ड लको अरू एक दुईवटा इक्जाम्पलहरूको कुरा गरौँ न त है त। जस्तै तपाईँलाई मैले हामी न्युटन्सको थर्ड ल हामीले नबुझ्ने हो भने हामी वाक त गर्न सकिहाल्छौँ नि, हामी हिँड्छौँ होइन, हामी के अरे we can walk, we know, right? So probably you might be thinking, why do we need to understand we can walk, right? Of course. But see, the goal of physics is to understand the nature. What is the goal of physics? What does physics do? It tries to reveal the facts hidden in nature. The facts are there. The laws are there. The laws of nature are there. What does physics do? Try to reveal the facts. Try to understand the facts. Try to bring them out. अब हामी हिँड्दैछौँ, हामीले न्युटन्स थर्ड लले काम नगर्यो भने हामी हिँड्न सक्दैनौँ। We cannot walk. We cannot walk. We cannot run. How can we do that? So when we walk, we push the ground. Okay? We push the ground. We push the road. Right? The road, the ground, the floor gives you reaction force. If you push more, you will get more reaction. If you push less, you will get less reaction, because action and reaction are equal and opposite. To every action there is an equal but opposite reaction. Right? So what will happen? What will happen? So when you push downward or backward, the ground pushes you, or the floor pushes you, the road pushes you upward or forward. Now, if you're simply standing like this, right, you cannot walk. What do you need to do? You need to push backward, right? So when you stand vertically, right, you will be pushed upward. If you want to jump, good. Push more and then jump, right? Right? So that's the Newton's third law of motion. Okay? Let's talk some other examples about Newton's third law of motion. Let me give you some time. Can you please think one example of Newton's third law of motion? Let me see what you are writing. Okay? Some of you, if you can type. So Newton's third law of motion. Okay? Let me ask you one question. Very interesting question. Okay? I have an apple on my hand. See? This is the same apple. By the way, this is not the apple of last week. My son ate that. Right? So this is a new apple, but of the same size. I have apple in my hand. I let it go. I let it go. Why? Why it falls? Because the earth pulls this downward. Right? The earth pulls it downward. Okay? तपाईहरुसँग क्याल्कुलेटर ह्यान्डी छ अथवा पेन र पेपर ह्यान्डी छ? Please do one calculation. Can you please do that? Please do one calculation quickly. मैले तपाईलाई भने थिए यसको वेट चाहिँ 1 न्यूटन हो है. यसको वेट चाहिँ 1 न्यूटन हो. मैले लास्ट क्लासमा भनेको थिएँ. तपाईहरुले हेर्नु भएको छैन भने मैले भिडियो युट्युबमा अपलोड गरेको छु, हेर्नुहोस्. यसको वेट चाहिँ 1 न्यूटन हो. That means earthले यसलाई पुल गर्ने डाउनवर्ड फोर्स चाहिँ 1 न्यूटन हो. The earth is pulling it downward with 1 न्यूटन force. Right? And यसको मास चाहिँ 100 ग्राम्स हो. 100 grams भनेको 0.1 kilogram. Because you need to divide 100 grams by 1000, which is 0.1. Right? अब तपाईले 1 न्यूटनलाई 0.1 ले डिवाइड गर्नुस् त प्लिज. हेलो, कति हो? 1 न्यूटनले 1 लाई 0.1 ले डिवाइड गर्नुस् त कति भयो? कति भयो? टाइप गर्नुस् त प्लिज. टाइप गर्नुस्. गर्नु भएन है? गर्नुभयो? ल ठिकै छ. ल म भनिदिन्छु तपाईलाई. 1 डिवाइड बाई 0.1 त्यो डेसिमल छ नि, डेसिमल हटाउने नियम छ क्यारे. माथि एउटा 0 थप्ने. 10/1. द्याट इज 10 एन्ड द युनिट चाहिँ मिटर पर सेकेन्ड स्क्वायर. त्यसको त्यो चाहिँ त्यो एक्ज्याक्ट नम्बर होइन. हामी 9.8 भन्ने गर्छौँ. त्यो नम्बर चाहिँ के हो त? त्यसलाई के भन्छ? एक्सलरेसन ड्यू टु ग्राभिटी. के भन्छ रे? एक्सलरेसन ड्यू टु ग्राभिटी. त्यो चाहिँ एभरेज भ्यालु अन द सर्फेस अफ द अर्थ हो है. त्यो चाहिँ एभरेज भ्यालु अन द सर्फेस अफ द अर्थ हो. कति हो? 10 मिटर पर सेकेन्ड स्क्वायर. टु बी एक्ज्याक्ट इट इज 9.80. प्लिज डोन्ट वरी अबाउट द्याट. वी आर एप्रोक्सिमेटिङ है त. हामी रफली हाउ मच इज द्याट वी आर डुइङ, वी आर एस्टिमेटिङ. राइट? अब हेर्नुहोस् है, मेरो फाइनल क्वेसन. आज सायद यो अब म 10 मिनट पछि एन्ड गर्छु यो भिडियो है त. सुन्नुहोस् है. दिस एप्पल इज फलिङ डाउनवर्ड with 10 meter per second square roughly. What does that mean? 10 meter per second square means in the beginning it was at rest. See, I am holding it. यसको भेलोसिटी कति हो? यसको कति भेलोसिटी झरेको छ? छैन, झरेको छैन यो. 0. अब तल झर्दै जाँदा के हुन्छ? 1 सेकेन्ड पछि यसको भेलोसिटी लगभग 10 मिटर पर सेकेन्ड हुन्छ. एक्ज्याक्टली 9.80 हुन्छ अन द एभरेज. बट लेस एप्रोक्सिमेट 10 मिटर पर सेकेन्ड हुन्छ है त. अर्को 1 सेकेन्डमा कति हुन्छ? अर्को 1 सेकेन्डमा कति हुन्छ? क्यालकुलेट गर्दै जान सक्नुहुन्छ तपाईँ. त्यस्ता क्यालकुलेसन हामी फ्युचरमा गरौँला है त. तर मैले तपाईँलाई सोध्न खोजेको कुरा चाहिँ यो हो. अब यो एप्पल तलतिर झरिरहेछ होइन? एप्पल मैले छोडिदिएँ, एप्पल झऱ्यो. केले गर्दा झऱ्यो? केले गर्दा झऱ्यो भन्नुहोस् त. लेख्नुहोस् न त, तल टाइप गर्नुहोस् प्लिज. केले गर्दा झऱ्यो? द्याट इज बिकज अफ ग्राभिटी. Right? Earth force. Earth is pulling the apple down. होइन? The earth is pulling this down. How much? With what force? 10 Newton. Sorry, 1 Newton. Sorry, let me correct. 1 Newton. 1 Newton. होइन? 1 Newton फोर्सले तानेको छ. अनि कति रेटले झऱ्यो? 10 मिटर पर सेकेन्ड स्क्वायर अन द अबाउट एप्रोक्सिमेटली. अब म तपाईँलाई क्वेसन सोध्छु. यो एप्पल तल झर्दा the apple is going down like this. Apple is going down. Now my question to you is, what is the force exerted by the apple to the earth? यो एप्पलले अर्थलाई माथितिर तान्छ कि तान्दैन? 1 मिनट थिङ्क गर्नुहोस् त. तान्छ? हेलो? Does this apple pull the earth towards it? Does this apple apply force to this earth upward? Does this apple pull the earth upward? Yes or no? होइन. Yes. 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 एप्पलले अर्थलाई माथितिर तान्छ, नभए त न्युटनको थर्ड ल नै फेल भइहाल्यो नि। ल इज अ established statement in physics, right? Newton's third law, these are established statements. त्यहाँ न्युटनको थर्ड ल त फेल हुनु भएन। अब भन्नुहोस् कति फोर्सले तान्छ भन्नुहोस् त। यो अर्थले यो एप्पललाई तलतिर 1 न्युटन बलले तान्छ, 1 न्युटन। The earth pulls the apple downward with 1 Newton force. Okay? With what force does the apple pull the earth upward? Can you please tell me? Hello? Yes? Yeah, it does. How much? With 1 Newton, with the same amount. Upward, with the same amount. Because to every action there is equal but opposite reaction. Action, force applied by the earth on it. Reaction, force applied by this on the earth, upward. तर एप्पल तलतिर झर्छ हैन, अर्थ चाहिँ एप्पलतिर जान्छ कि जान्न? अर्थ चाहिँ एप्पलतिर जान्छ कि जान्न? Does the earth accelerate towards the apple? The apple is accelerating downward with 10 meter per square second. Per meter divided by second square. Per meter per second per second. Does the earth accelerate towards the apple? तपाईलाई यो क्वेशन मैले छोडिदिन्छु है त। नेक्स्ट टाइम आई एम एक्सपेक्टिङ आन्सर इन द नेक्स्ट टाइम। ओके, र यति भनेर म फेरि अब के गर्छु भने मसँग कति मिनेट बाँकी छ? मसँग 7 मिनेट बाँकी छ। म समराइज गर्छु। लेट्स समराइज टुडेज क्लास। I hope you enjoyed it. Thank you so much for attending this Facebook Live. Okay. So, in next 7 minutes, I will summarize. Okay. Newton's 3 laws of motion. Newton gave 3 laws of motion. What are they? First law of motion, second law of motion, third law of motion. Newton gave first law of motion, second law of motion, and third law of motion. So, what are those laws? How do we state? The first law tells us, let's summarize. First law tells us that every object in the universe, if it is at rest, remains at rest unless we apply external force. This is also called Galileo's law of inertia. If an object is at rest, it will remain at rest. If it is in motion, it will remain in motion. Unless you apply external force. That is the first law of motion. Sometimes it is also called Galileo's law of inertia. If an object is at rest, it remains at rest. That is inertia of rest. If it is moving, it keeps on moving. That is inertia of motion. Make sense? Second law, when you apply force on an object, if there is a net force, if there is a resultant force, I am using a new term now, if there is a net force, the object accelerates. How much is the acceleration? How does the acceleration behave? Acceleration is directly proportional to force. What does that mean? If force is more, acceleration is more. If force is less, acceleration is less. Under the condition that you will keep mass constant for the same mass. So acceleration is directly proportional to force. If mass is kept constant, acceleration is inversely proportional to mass. If force is kept constant, that means if the masses become heavier and heavier, for the same force, acceleration will be less. We talked about the example of a bicycle, a motorcycle, a car, and a bus all stuck in mud, right? And if you apply the same amount of force, you will see acceleration higher in bicycle, right? You will see acceleration lowest in the bus. And finally, the third law of motion. To every action, there is equal but opposite reaction. Right? To every action, there is equal but opposite reaction. तपाईँ जति फोर्स दिनुहुन्छ कुनै अब्जेक्टमा त्यति नै फोर्स चाहिँ त्यो अब्जेक्टले तपाईँलाई दिन्छ. ए भन्ने अब्जेक्टले बी भन्ने अब्जेक्टलाई पुश गर्यो भनेको ए भन्ने अब्जेक्टले बी भन्ने अब्जेक्टलाई जति फोर्स दियो बी भन्ने अब्जेक्टले ए भन्ने अब्जेक्टलाई त्यति नै तर अपोजिट डिरेक्सनमा फोर्स दिन्छ. ओके, मेक सेन्स? जस्तै पृथ्वीले सूर्यले पृथ्वीलाई जति फोर्सले सूर्यले पृथ्वीलाई जति फोर्सले तानिरहेछ टुवर्ड द सन त्यति नै फोर्सले चाहिँ अर्थले सनलाई तानिरहेछ. द सेम थिङ फर द मुन एन्ड द अर्थ. द सेम amount of force for the apple and the earth. The same amount of force for any two objects which are interacting with each other, right? अब सुन्नुहोस्, मेरो अब यो सेसनको लागि लास्टमा 3 मिनेट बाँकी छ. अब 3 मिनेटमा चाहिँ अलिकति फरक कुरा गरौँ. 3 मिनेटमा अब आज न्युटन्स लको विषयमा मैले कुरा गरेँ है त. यहाँहरूले मन पराउनु भयो भने स्वस्थ भाषामा, शिष्ट भाषामा कमेन्टहरू लेखिदिनुहोस् है त. लेख्नुहोस् न. मन पर्यो भने मन पर्यो भनेर लेख्नुहोस्, मन परेन भने मन परेन, यो कुरा चाहिँ इम्प्रुभ गर्नुहोस् भनेर लेख्नुहोस्. तपाईँहरूसँगबाट म सिक्छु के है. मैले सबै कुरा जानेको छैन. 28 वर्ष भयो पढाएको, तर दिनै पछि नयाँ नयाँ कुरा सिकिरहेको छु. आई एम लर्निङ एभ्री डे अ न्यू थिङ. सो I hope I will learn something new from you. Thank you for attending this session. I appreciate your 1 hour time. हैन, तपाईहरुले मैले अघि गरेका जुन डेमोन्स्ट्रेसनहरु छन्, एक्सपेरिमेन्टहरु छन् नि, घरमा गर्नुस् है. बालबालिकाहरुले गर्नुहुन्छ भने तपाईहरु चाहिँ पेरेन्ट्सको हेल्प लिनुस् है त. सुरक्षित हुनुपर्छ. फर्स्ट इज योर सेफ्टी, राइट? कुनै पनि एक्सपेरिमेन्ट गर्दाखेरि तपाईलाई चोटपटक लाग्यो भने द्याट मेक्स मी फिल अनह्याप्पी. ओके, सो प्लिज स्टे सेफ एन्ड डु द एक्सपेरिमेन्ट्स, लर्न साइन्स है त. अब म 1 मिनेटमा चाहिँ यो फिनिस गर्छु अनि म युट्युबमा पनि अपलोड गर्छु है त. तपाईहरुले यदि सेयर गर्न चाहनुहुन्छ भने युट्युबबाट सेयर गरिदिनु भयो भने अरू साथीहरूले पनि हेर्ने मौका पाउनुहुन्छ. मेरो अब्जेक्टिभ भनेको पनि त्यही हो. धेरैभन्दा धेरै स्टुडेन्टहरूले, धेरैभन्दा धेरै विद्यार्थी भाइ बहिनीहरूले चाहिँ यसबाट फाइदा पाउन्, उनीहरूले सिकुन्, उनीहरू मोटिभेट हुन्, उनीहरूले चाहिँ फिजिक्स सिकुन् भनेर चाहिँ मैले फिजिक्स इज फन को चाहिँ प्रोग्राम चलाउँदैछु. म मेरो युनिभर्सिटीमा पनि म ग्रेजुएट स्टुडेन्टलाई, पिएचडी स्टुडेन्टलाई होस् अथवा अन्डर ग्रेजुएट स्टुडेन्टलाई होस् अथवा हाई स्कुलका केटाकेटीहरूलाई पनि मैले समरमा पढाउने गर्छु. म तिनीहरूलाई भन्छु फिजिक्स इज फन. हस् त, नमस्कार. थ्याङ्क यू सो मच. बाई. सी यू नेक्स्ट टाइम, नेक्स्ट स्याटरडे.